Assalamualaikum, Tashinhao, and welcome to all the respected judges. My name is Muhammed Syazani bin Muhammad Syamsulbahrin, matrix number 192340, and I am a final year student in Bachelor of Mechanical Engineering with Honors, University Putra Malaysia. Today I'm going to present about my final year project entitled Reducing Logistic Costs Using Genetic Algorithm. Let's start with the project outline. Alright, so basically this project focused to study about the background of logistics and also simulation optimization in order to analyze the problem that related to the logistic cost and how to overcome those problems by having a good methods. Besides, there is also a comparison between theoretical and experimental data in order to prove that this project can reduce the logistic cost. Hence, there is also a study about the impact of the project towards the environment, especially society, health, and also the safety. Now we proceed to the background study. Basically, logistics can be known as a managing method on how resources obtained, processed, and delivered to their final destinations. It is important to handle the logistic precisely in order to avoid logistic waste. It is because logistic waste can cause the business value over time and resources become waste. In addition, when there is logistic waste, it shows the efficiency in the logistic department on how they manage it. Hence, a good method is needed to overcome those problems by having a better route planning to deliver the resources to their final destination by simulation optimization or swarm intelligence. For your information, swarm intelligence is the collective intelligent behavior of simple agent, such as we have it particle swarm optimization, we have ant colony optimization, and more. For the problem statement, Kishavdas 2021 found that 30% of total expenditure comes from transportation account, and this figure could rise up to 50% due to the increasing fuel price. This becomes a worry toward the logistic company because they cannot regulate fuel costs. However, they can certainly control the fuel spend. How? By having a study about the routine issue is in logistics with the aim of minimizing transportation costs in terms of fuel consumption by having a better route planning, or we can call it a shortest distance to transfer to deliver the product to the customer. At the end of this project, there are two objectives that need to be achieved, which are the first one is to compare the theoretical and experimental data of shorter distance travel using genetic algorithm. Second, to verify that the shorter distance can reduce the logistic cost. Now, we proceed to the methodology part. Figure 4.1 shows the research flowchart. This flowchart is important for us to get a better understanding on how this project will be conducted. As you can see in figure 4.1, we start with the understand about the problem. The problem is related to the reducing logistic costs. So how to overcome it by having a shorter distance to optimize the fuel consumptions. Next, we need to develop the environment of research with related to the location of customer. Then we set a parameter, the first location, the last location, number of city, and then we write the coding into the MATLAB. Does the finding identify? If no, check back at the coding. Maybe there is some error. If yes, we can go to the final step, which is to prove that this research can achieve both objectives. Now, I will show the simulation optimization using genetic algorithm in MATLAB to find the shorter distance. After the coding of genetic algorithm is done in MATLAB, first thing first, we need to specify the first city and the last city. As we know, the first city and the last city is the coordinate of the distribution center because the simulation start from the distribution center to the customer location and then return back to the distribution center. Then we need to specify the number of cities. As you can see in the screen, the coding is now run in order to get the results. Here is the result of optimal route solution that need to be followed by the truck driver to deliver goods to the customer. Then we have a result of minimal total distance and also optimal solution. Simulation is done. Simulation is done. Now we proceed to the result and discussion. Alright, so move to the theoretical analysis of shortest logistic route. As you can see, In Table 5.1, it is a possible outcome for the shortest logistic route that can be done by manual calculation. However, this method is not good to be practiced because it's more time consuming. Besides, this Table 5.1 can be used as a table to check the results validity. Then, for the next slide, Table 5.2 shows the coordinate for distribution center and also customer location. Location 1 and location 11 is the coordinate for distribution center. Meanwhile, location 2 and 10 is the 9 customer locations. Besides, distance travel can be calculated by using the equation in the red box. Alright, so figure 5.1 shows the route option according to the sequence for the theoretical analysis. And we obtain the total distance traveled by truck according to the sequence is equivalent to 275.9 kilometers. Now we proceed to the simulation optimization of shortest logistic route using genetic algorithm. As shown in figure 5.2, it was the result come out from the simulation in MATLAB. The blue line shows the minimum distance traveled via simulation. Meanwhile, the red line shows the distance traveled according to the theoretical sequence. Next, figure 5.3 shows the result from the simulation optimization of genetic algorithm in MATLAB. From the column window, we can get the result of minimal total distance equivalent to 17.7966 units. Meanwhile, the optimal solution based on the coordinate is shown in the red circle. By doing the simulation, the minimum distance traveled by truck to deliver goods to the customer is equivalent to 177.97 kilometers. Now, we move to the crucial part to prove the second objective on reducing the logistic costs. Before that, figure 5.1 shows the diesel price, which is 2 ringgit 15 cents. For your information, this truck uses a diesel fuel in order to deliver the goods to the customer. In order to prove that this project can reduce logistic costs, first thing first, we need to calculate logistic costs before optimization. For information, distance travel before optimization according to the sequence is about 275.9 km. Then we substitute those information into the equation of fuel cost before optimization and we get the answer is about 138 ringgit 21 cents. Next, we calculate the logistic cost after optimization. The distance travel after optimization using the simulation of genetic algorithm in MATLAB, we get the answer is about 177.97 km. Then we substitute into the fuel cost after optimization and we get the answer is about 89 ringgit 15 cents. Next, the most interesting part is on reducing the logistic costs. The first thing first that need to be done is to calculate the reduced distance. The reduced distance before and after optimization is about 97.93 km. Meanwhile, the cost saving in logistics is about 49 ringgit 16, and then the percentage of the cost saving in logistics is about 35.5%. It was such a huge amount of cost saving in logistics that will benefit to the company. Alright, settled with the result. Now, we've proceeded to the impact of this project towards environment, especially societal, health and also the safety. As we know, when reduced logistic costs and logistic waste will lead to the positive growth of company profit for a long-term period. For instance, during this pandemic, a lot of people doing business, so I think this project can help them to optimize their profit in order to success in the business. Besides, this project also will increase the satisfaction of customer. Why? Because this project can make those items can be delivered on time. In addition, with less fuel consumption is used, so it will provide a better environment for nature and also for our health. Why? For information, diesel fuel contain a lot of chemicals such as nitrous oxide, which is not good for our health. As shown in figure 6.1 and figure 6.2 is the example of disease that can be obtained from the exposure of the diesel. In conclusion, the first objective was achieved by using genetic algorithm, where the shortest distance traveled is about 177.97 kilometers. Hence, from the comparison of the theoretical and experimental data, the safe distance traveled is about 97.93 kilometers. In addition, the second objective also was solved, where this project can reduce the logistic cost up to 35.5% in terms of diesel fuel consumption. I think that's all from me. Any inquiry can reach me via WhatsApp or email. Thank you and stay safe. Bye bye.